We've just talked about heat, the component of the internal energy changes we were looking at for a system to know if it's exothermic or endothermic. And so our heat is that transfer of energy in between a system and surroundings. But energy can transfer it another way too, and it's work. And so I want to take a moment to talk about work here for a second, the component or a component of that change in internal energy. So, in terms of chemistries, in chemistry, the type of work that we see done is typically pressure volume work. And this then is when we involve gases in our chemical reaction, which are not all of the time. It's a subset gas evolving or gas consuming chemical reactions. And so, a lot of times, chemists are going to simplify this idea of internal energy change by looking at the heat only. And we'll talk about that in a coming lecture. But let's take a look at the type of work that we commonly see in a chemistry context around internal energy change. So pressure volume work is work that's caused by the volume, a volume change against an external pressure. Remember that work is equal to force time over a distance. And so our pressure, um, which is something that we'll talk about in more detail when we talk about gases. But pressure is a physical property that we can track for gases. And it's related to the force of gas particles as they collide with a surface over that area that they're colliding into. So it's really pressure is gas particles zooming and hitting the surface of an object. So my hand, for example, is experiencing pressure from air molecules that are colliding with it and exerting pressure over the area of my hand. And so the pressure of a gas is how much force is being applied to the area of the spaces of its container. So maybe that's the walls of the room or of a beaker or our bodies or my desk, right? And and volume in this piece is really we can break that down into area times height, right? Combining these two, if we look at the change in volume times pressure, we'll see that the areas cancel. We're really looking at that force from the pressure times that height, which then looks like our work function. So when a gas expands, when a chemical reaction produces a gas and that gas expands out, we have a change in volume that's positive for that chemical reaction. It's going to get bigger, right? So we have a positive change in volume. And what's happening is that the system, that chemical reaction, is pushing on the surroundings, the atmosphere around it, and pushing it back to make space for this new volume of gas produced. And so that work is being done from the system to the surroundings. And so that will be a negative sign for our work function in this. Now, conversely, if we have gas consumed in a chemical reaction, then as this reaction proceeds, the volume around it will get smaller as it consumes gas. What we'll have is the change in volume will be negative, and the atmosphere will be pushing in on the volume of the reaction, and we'll have a positive change in work for the system, which is that chemical reaction. Remember, this is all relative to the system. And if we define that as the chemical reaction, our work then will be negative as that gas is consumed. So we can, in general, calculate work for our chemical equations by multiplying the negative of the pressure of the system times the change in volume that it undergoes. So that way, if our change in volume is negative because it gets smaller, we'll have a positive value for work. And if it's a positive change in volume as it expands, we'll have a negative value for work done by the gas. And this is pressure volume work.